Good afternoon. I'd like to introduce our speaker for this afternoon. The gentleman here on my left here, and on your right, of course, you're looking out there, is Dr. Doug Plata. He's going to talk quickly, how quickly can a Mars colony become completely Earth dependent? Independent. Not dependent, independent, right. So go ahead, doctor.
Okay, thank you. Appreciate that, and thank you. Yes, it will start as Earth dependent for sure, but the question is how quickly could it become Earth independent? And I am proposing that it could actually become completely Earth dependent relatively quickly, and that's what we'll get into. Did I say that? This is not going to go well, I can tell. Okay. Basically, I want to go ahead and say that. Let me start with maybe some definitions. Achieving Earth independence. I am actually going to be. Well, I'm not sure. It's looked like there's a possibility we might have actually a track to discuss the different aspects of this at the National Space Society's International Space Development Conference. But first of all, let's get to the question of why. Why is becoming completely Earth independent for a base on Mars, why is that something that would be something good? I think it would be good. I think everybody would say that, but specifically why? Well, you need to understand that becoming Earth independent, meaning that you ship less and less stuff to Mars until you don't have to ship anything more. Obviously, it's going to go ahead and reduce shipping cost if you don't have to ship so much. Ship so much. Yeah. But also, if you think about the security of supplies, if you're just totally dependent upon what's being shipped from Earth, if something goes wrong with that shipment, then your base is in trouble. And so it'd be nice if you're able to produce your own water, for example, then you don't have to have it shipped from Earth. And of course, I would say ultimately, it's the whole survival of the species. It's having your eggs in more than just the Earth basket. But there's a fair amount of difference between the first two rationale and the last two, as we'll see. So let's talk a little bit about reducing cost. Pretty straightforward. If you're able to produce 50% of your mass on the surface of Mars, then you don't have to go ahead and ship that. That either means you launch less frequently, or more likely that you can actually accelerate the development of your base because in really moving forward more quickly towards actually settlement, if you can be shipping more of the stuff that you're not able to produce on Mars, and the more that you're able to produce, the less you have to ship. But then there's the security of the supplies. Now, by supplies, I mean things like complex parts, maybe electronic things that you cannot easily produce on Mars. If you can go ahead and produce that and stockpile it, you just got that reserve. So the security of your supplies is enhanced. But frankly, I'd like to really focus this presentation on this whole idea of being able to secure the human species by becoming completely Earth independent. When we think about risk, why do we need to have a separate basket for humanity? What is the number one reason that people give for why humanity could be extinguished on Earth? What's the thing that, if you read an article about it, what's that? Nuclear war? Plague? Asteroid is what, normally you see an article about it. It's got this classic picture of this, some sort of almost, something the size of Ceres hitting the Earth, something like that. But actually, if you really look into this issue, the natural causes of extinction are quite improbable. They're not zero, but they're quite improbable. And that's everything from asteroids to supervolcanoes to what's it called, the explosion of space, puts out galactic, supernova, yeah, nearby. Quite low probability. It's highly likely we're going to develop cities on Mars before any of those events happen. Certainly we could be hit by a Tunguska sort of thing and maybe hit a city, and that would be a bad day, but that's not going to be the end of human civilization. In terms of things like nuclear war, certainly that would be a very, very bad day, if we were to have nuclear war. But if you do the math, humanity could not be destroyed by the initial blast if you do the math. And the whole nuclear winter sort of thing is probably not sufficient, especially in the southern hemisphere, where it'd take a long time for the radioactivity to cross the equator. And after 2 weeks, you can come out. So I think people would even survive a nuclear war. But it is the self-replicating technology. This is really where the greatest danger is, I think, by far. And so we're talking about like biotech. You've got the potential for self-replicating chemicals if we could just start having technology that is able to print any chemical that you enter into the computer, and you hit the button, and lo and behold, it does it on sort of a nano manufacturing scale. And if there is a self-replicating chemical in chemical space that would, for example, consume atmospheric CO2 to completion, that would affect everywhere that the atmosphere goes, which is the entire Earth. And so that could jeopardize plants, animals, and people. And then there's the gray goo scenario in which you have sort of advanced nanotechnology that self-reproduces and just consumes stuff all over. And then AI, I think a lot of us know about that. I don't really have a solution for that last one. But for the first three, I think that if we were to go ahead and have a completely self-supporting base off Earth, it could really help human species survive that. So the reason why I make a distinction between the reducing cost and securing supplies and these extinction risks is because any level of self-sufficiency will help reduce cost and help ensure your supplies. So you get the benefit there. But if you're only partially self-sufficient and then something bad happens on Earth, it's insufficient. You got to be completely self-sufficient. And this is a graph that sort of illustrates that point. And if you're 50% self-sufficient, it will reduce cost, it will secure supplies, but you got to be 100% producing what you need in order to survive for the species. Okay, there's different types of Earth independence. Normally, space advocates think about becoming completely self-sufficient. Generally, we think about in terms of, in the general sense, and this is sort of the cities on Mars. We need 1 million people on Mars because you need industry to produce computer chips and things like that. And so the idea is that you'll need really a large number of people to become Earth independent. But there is another way of looking at it, and that is what I'm going to term a prepper colony. And by that means it's really a small but self-sufficient little colony, and I'll explain that. So the idea of general Earth independence would be large cities, maybe multiple settlements in different places, and between them there's actually the ability to be completely Earth independent if it came to that. But a prepper colony could be really quite a bit smaller, and I'll explain just how small. For a prepper colony, it could look something like this, because if you really want to secure yourself from whatever is emerging from Earth, a self-replicating technology, I think there's value in having the prepper colony actually be physically separated from the supply chain from Earth. If there is some sort of self-replicating biotech you would like to be able to have a place here to the left in which your supplies could land, and yet your colony does not go out to access those supplies immediately. You keep in contact with Earth. If everything's going on Earth, then after 6 or 12 or, I don't know, a few years, you go out to the supplies and you figure, well, it was delivered from a living, healthy Earth, and so therefore those supplies are not infected with whatever agent it might be. So if we think about what would be actually necessary to become completely Earth independent, I'd like to suggest that there's 2 ways of reasoning. There's maybe more, but let's go with these 2, and that is reasoning from analogy and then reasoning from first principles, okay? So reasoning from analogy would go something like, well, on Earth we've got big cities, and so we, in industries, you know, around the world now supply our needs. Therefore, on Mars, we need large cities to supply all of our needs, okay? Or you can think about it from first principles, which is asking, what really are the things that are necessary in order to become completely Earth independent? And so you might think of it in sort of by analogy to Maslow's hierarchy of needs, in which you start very fundamentally and ask, okay, what are the basic things, and then what do you need to be able to supply those things? And you don't just automatically jump to the conclusion that you need large cities to do that. And so I believe that if you look at it from first principles, that it turns out you don't need it anywhere as large as full-size cities. Okay, so here's the list I've come up with, and I'd certainly be open to additions or subtractions to this list. But I put it in terms of categories, how immediately do we need these things? There are certain things, if you don't have it, you're going to die within minutes to hours. And that would be like air pressure, oxygen, temperature control, power. If you don't have these things, you're going to freeze to death or you're going to, you know, suffocate. And then there's those items that you need that are days to months. If you don't have it within days to months, you're going to die. And that is like drinkable water, food, equipment, the ability to reproduce parts in the habitat, radiation protection. You're probably going to get a solar storm that's going to kill you on average in, you know, I don't know, a year or 2. And sanitation, you might start getting sick. And then there's certain things that will kill you eventually, but could take a very long time. You need to have isolation, otherwise in the next shipment you might get infected. If you don't have sufficient gravity, this might be a problem in which you could end up suffering some health consequences, but that's over a period of time. If you don't have the information to be able to move on to develop the rest of the material, the supplies that you need, you're eventually going to use up your supplies and you're not going to know how to replace them. Genetic diversity is more on a generational sort of level. And then translocation or escape, and that is, you know, eventually whatever planet you're on, you're going to use up the resources, and so in order to survive indefinitely, you need to go ahead and escape elsewhere. So how can these requirements be met at the earliest possible time? So I want to introduce this concept. It's sort of a mathematical way of reasoning through this, and that is percent mass independent, and you can actually put a metric on the degree to which you are mass independent. And that is the percentage of mass that you don't have to supply because it is being produced by in situ resources. So let me give you an example. This is not too hard to understand. If you have 0% production at your base, you have no ISRU production, you're 100% dependent on Earth. Everything that you use, you got to have shipped, okay? If you're able to produce 50% of the mass that's shipped, then you're 50% Earth independent. If you're producing everything, then you're 100% mass independent. I think pretty simple to think about if you just stop to think about it. So here is a list that I've come up with of different categories of masses, and I think somebody needs to do a formal study on this to be able to actually calculate these numbers, run them through the rocket equation. But these are just estimates that I've come up with. The percentage of the mass that you're shipping, like from low Earth orbit to a Mars base, I roughly, don't hold me to these numbers, but 45% might be descent propellant, 23% ascent propellant, 10% water, that's for like consumption and for growing food, inflatable habitat material, gross metal parts, on down the line. Electronics is a relatively small percentage of the mass that you're going to be shipping, okay? But I'd like to point out, and certainly people can argue with these numbers, they're probably wrong in some way, but if you think about, on Mars, we've got this wonderful thin but atmosphere present, and that gives you your carbon, nitrogen, and oxygen. And then from the water, you get water and you get hydrogen and oxygen. And so if you have a source, and we could do this fairly early with a base, you can access the atmosphere and you can access water in terms of ice in the ground. And if you start using those things immediately, you can start producing a large proportion of the mass that you have to ship, especially propellant mass, which is the bulk. And so, who knows, but maybe about 80% of your mass you could actually produce relatively early, just as long as you're accessing those two resources and using them to grow food and whatnot. Okay, so recycling is perhaps the unsung hero compared with like ISRU or even lowering launch cost. And there is this formula in which the R is for the recycling efficiency. For example, on the ISS, it's 93%, got that? 93% of the water is recycled. Okay, when you put it through the formula, that means the equivalent of shipping 14.3 liters if you didn't recycle, and only 1 liter if you did. So it's a huge factor in terms of reducing shipping cost. You know, if you think about how much money is being saved by partial reusability, it's impressive what SpaceX has done. But recycling, humble though it may be, is a great way of being able to reduce your shipping needs. And I'd say there's categories of easy to produce material or parts and more difficult to produce parts. Another concept would be sufficient supply. Bear with me, this is, I think, an important idea. It is, you've established a base and then you oversupply it to buy time in order to implement technology protocols to produce the remaining parts, okay? So, say for example, if you are not supplying at all, after a period of time, you're gonna die. If you are partially supplying it, it will simply buy you more time. If you are completely self-sustaining, if you reach that goal, it's going to take you a while to get there, and then eventually you're home free. You produce everything that you need. But what you could do is you could oversupply the base. That's going to buy you some time to be able to implement the technology protocols. Even while you're supplying the base, you could be implementing these protocols. And then after a while, you're actually getting to the point to where you're living off your oversupplies, and you are then able to buy the time to implement the protocols so that you are now completely self-sustaining. But you didn't need shipment from the Earth after a certain point in time, even before you reach the point where you're producing everything that you need. Okay. How long can supplies last? Let me give you this example. Here's a 1x1 meter box. Just think about it. How many modern CPUs could you fit within a 1x1 meter box? My calculations are like 2,000, okay? We don't get rid of our computers because the CPUs have burned out. We get rid of them because there's something new, right? So those CPUs can last maybe decades, okay? How long would 2,000 CPUs last you? And that's just a 1x1 meter box, you know? So these items, such as electronics that are high information but low mass, is something that you can, relatively small amount, you can buy yourself a large amount of time by shipping those things. So I apologize, overly ambitious, so I'm going to have to really fly through. So metallurgy, certainly we do recycling. On Mars, these are actual pictures of metal meteorites on Mars. So there's an immediate source of metals. In the moon, that's like 1% of the highlands is micrometeorite bits. You could if you need to, you could get metal from the regolith by separating the oxides, but really there would need to be exploration for ore. I think ultimately would be the long-term solution for providing metals for self-sustaining. For production, in the initial crew, I think you could have a machinist metallurgist, starting with the easy to produce metal parts, just like housings, but that's a lot of the mass. The hard to produce parts would come maybe a little later, and you can oversupply those. And then you can do anything from casting to making sheet metal to 3D printing with the end goal of producing a lot of parts. Chemistry, I think initial crew, you need a chemist and a geologist sort of working with organic and inorganic chemistry. Again, the atmosphere of Mars provides a lot, basically what you need, except for the hydrogen, for organic chemistry and for inorganic chemistry. That's where I think surveying the area to find sources of different elements comes in. And then as the base grows, you can have dedicated habitats to production of chemicals on a semi-industrial scale. Power systems is maybe going to be a real problem on Mars because you can use solar power. I think there's still a place for it, but I think ultimately you need to go nuclear, which means to be able to reproduce nuclear, I think is a high bar. It's probably doable, but it would take some work. Habitats, I think inflatables gets you a long ways initially, but eventually you got to go with local ISRU construction. Food, I think there's a lot of good work that is done and is being done. I think that's a technical challenge, but very solvable. It's just a lot of work to do that. Electronics, we don't need modern CPUs to run things. We got to the moon using the thing there on the left, okay? So to run a rover, you can start with your supply of excellent CPUs, but you don't necessarily have to produce that same level eventually to have a working system. You can maybe produce something along the line of the 8088 chips. We might be able to have that capability. How much more time do I have?
We have 4 minutes for questions.
Okay, 4 minutes for question. Artificial gravity, indoor centrifuge. I apologize, I'm just going to fly through this. Yes, let me mention about genetics. The minimum viable population, I don't think it's 10,000 people or whatever. History of settling of the islands in the South Pacific, I think, had far fewer than that. So you can go ahead and very early on ship frozen embryos, and they do last decades. Here's a protocol for how you find out the artificial gravity prescription for healthy gestation and childhood, with that being the ultimate goal. And you need to train people, and you need to give them information to do other jobs that the initial crew don't know how to do, haven't been trained. And then you do need to develop technology to move elsewhere. I'm going to pass over the biopreserve. So I would say if the BFR comes into reality, I think that's going to accelerate things tremendously. And here is my suggested estimate of how long it would take. I think it would be, we could possibly do this in a few decades, 3 or 4 decades, 5 decades, something like that. And the significance is really, I think, very huge because it's ensuring the long-term survival of humanity. There is something that we can do. I'm working with the Tucson L5 Space Society. We would like to be able to create a Moon-Mars analog base in which we can demonstrate development and settlement sort of technologies. So with that, 3 minutes? Yeah.
Have you talked to Bruce McKenzie about the Mars Homestead project?
So I know, I've met him and I know about him, but I probably need to speak with him some more. So I appreciate that. Okay, excellent.
I agree with your question, but to me, there is one other rational issue for it. It is that the financing, the funding of this project could endure only a certain number of years, and after, let's say, 20 years, you have to have a
Okay.
The investor would like to do greater.
Okay, so that's a really great point. Let me just go ahead and address that. There's different sorts of sustainability, and one of those is financial sustainability. But I think technical sustainability is the most important thing. If you are cut off from Earth and you're cut off from all of those markets, you could still have a group that's motivated to survive. And so technical sustainability, I think, is number one on the list. Yeah. I think for the cities, I think there needs to be some sort of economic sustainability. Let me get some new hands here. Yeah? Okay.
To what extent do you think advances in 3D printing that allow high temperature and high strength materials that can substitute for what traditionally needed to be metals will be helpful, say, within our lifetimes to produce things if we cannot find ore on Mars quickly?
Are you talking like making ceramics?
Well, I'm talking about 3D printing materials, for example, rocket engines, things that traditionally had to be made of metal, but I understand there's work being done on having high temperature and resistant and high strength materials that can be made from non-metal feedstocks.
Interesting. I was not aware of that. Maybe we could chat afterwards, and I'd love to find out about that. All right. Thank you for your attention.
Give him a big thank you.